All right, guys. Hey, welcome back. This will be part two of completing the square. The first part we talked quite a bit about, let's see, square root property, how to make a polynomial a perfect square, and then how do we actually complete the square, all right, and the process behind it. Today's video, a little bit smaller. We're only going to really discuss what happens with completing the square when we have a variable, when we have a coefficient that isn't 1 in front of this guy. Okay, we'll know some of the differences. Not that many differences, to be perfectly honest. We'll do two examples, and then if there's time, we'll talk about imaginary. It's really the same process. Your answers will be imaginary. So we'll see. We'll go with the flow. All right. Okay. My first step, once again, like the previous lesson, I'm going to go ahead and just separate the constant from, I'm having a hard time talking today, the constant from the quadratic and linear term. Now notice, because I have these two guys that aren't exactly 1, and to keep in mind, I want to make this a perfect square trinomial, I'm going to factor a 5 out for both of them. Okay. Now this is going to accomplish two things. One, it's going to allow me to create a perfect square trinomial. Okay. And two, I don't have to worry about a value in front of here. Okay. It's going to make it a lot easier for me to factor this. So let's take a look. Factors of 4 was what? 2 and 2. And if you remember, the pattern was you take half of this guy and square it. Okay, so this ends up being 4 over here. Ironically, it doesn't always happen that way, but it did this time. Now, for my next step, we talked about, we have an issue. Because I added a value here, this is no longer the original equation. Because up to this point, look, all I did was add parentheses and factored out a number. I didn't change the integrity of the actual equation itself. But now since I added this 4 in here, it's no longer the original. So I want to make sure I don't do that. And typically we took this value and we subtracted it outside of here, we were done. I can't do that. It doesn't work. You know why? Why can't I not just take that number and subtract it? That's right. I'm going to assume what you said is correct. I have a 5 out here. I factored a 5 out. Is this really a 4? No, it's actually a 20. So I want to subtract 20 on the outside here. Now, if I combine everything, multiply, and make everything nice, it's going to be the original equation all over again. Okay, so now we're going to factor this guy. It's just what? X plus 2 squared. Subtract those two guys, we get negative 45 equals 0. Up to this point, we pretty much have been complete the square. Now this is like the square root property territory that we're getting into. Now we're just going to solve what we did normally. I'll add 45 to the other side. So 5 times the quantity of x plus 2 squared, and then equals 45. Divide both sides by 5. X plus 2 squared equals 9. What do you think? Do I have enough space? Maybe? Maybe. To solve for x, we're going to square root both sides. I'll get rid of the exponent. I get x plus 2 equals positive negative 3. Don't forget, there's two cases when you're taking the square root. I didn't have enough space. I'm going to have to go off to the side here. I have two different answers here. When I subtract 2 to the other side, I could have negative 2 plus 3, or I could have negative 2 minus 3. The first one's going to yield a 1, and the second one will yield a negative 5. Those are both of my answers to this problem. What do you think? Not that bad. There's only two things you have to be cautious of. One, when you see this, whatever's in front of here, 4, a half, a million, you're going to factor it out. You want to make this guy a 1. Okay? It might make everything else whole numbers. It might make them not whole numbers. Just depends. Afterwards, when I subtract like I normally do, remember, it's not just this number. It's this number times the factor you pulled out. Okay, so it becomes negative 20, and then the rest just kind of goes along pretty much the same, huh? Not too bad. Pretty cool. Should we make it messy? Put some fractions in this? Yeah, let's put some fractions in this. And what do you think? Let me move the camera. There we go. Okay, another example. I mean, like I said, this one's going to have some fractions involved, but hey, that's fine. We can work with them. Some people will convert to decimals. If that's what works for you, that's fine. Is there a right way or a wrong way? Depends on you. Depends on your level of comfort when it comes to messing with these numbers, and your teacher, honestly, right? Okay, first step, I'm going to factor a 3 out of everything. But before I do that, let me just group them. I don't want to skip too many steps. I want you to be able to follow along. Now I'm going to factor a 3 out. And when I do that, well, here comes the fractions. Okay? You don't have to put a line here when you're solving it yourself. I'm doing that for emphasis. Now, what number in here would make this guy a perfect square trinomial? Because there's a fraction, some people usually pause. They don't know what to do. So let's doodle. Okay, let's do something off to the side. Let's talk about this for a second. Over here, to figure it out, I took there we go. I took half of this guy and squared it. That was the pattern, right? We're gonna do the same thing. So in other words, what's half of 10/3? Okay, well, if I take half of it, which is like multiplying by half, I get 10/6. Now I'm going to square that, and I get 100/36. That's what this guy's going to be now. Okay, so it's going to be 100/36. Alrighty, now let's think about our next step for a second. If I take half of this guy over here, oh, jeez. I keep pulling it out, taking it out of frame, putting it back in frame. If I take half of this guy, wasn't that just the factors, right? That we pretty much used. So coming back to this, just because it's a fraction doesn't mean anything else. Half of this guy was the fractions, or the factors. So it'd be x plus 10/6. Which is this guy up here, right? So we just did off to the side as a little bit of practice. Now, what do I subtract on the outside? Well, remember, it's not just this guy, it's 3, the factor, whatever it is. In this case, it's 3. It's 3 times this. So we're going to subtract 300/36. There's some fun numbers going on here, huh? Okay, next, I'm going to just combine some stuff together. So over here, well, I'm thinking let's reduce this guy, be a little bit easier. I'm going to subtract 8, then minus. 12 can go into both of these. I get 25/3. I am taking extra steps to simplify this fraction. Just, you could do all this in one step, that's fine. Common denominator would be 3, so if you want to write this over 1, sometimes that helps. So that would make this guy a 3, and this guy would be what? -24. If I'm subtracting 25, it would be -49/3. Okay? Don't shy away from this. I'm not losing you yet, okay? We're okay. This is still manageable, right? Let's move the 49/3 on the other side. Okay, I'm officially out of room. Well, we're just going to have to try to make some space up here, right? To solve this, just like we did in the previous one, let's get rid of the 3. Okay, so we're going to divide both sides by 3 since we're multiplying. If we're dividing this by 3, it's like you're multiplying by a third. So it's going to be x plus 10 over 6 squared equals 49 over 9. To get rid of the exponent, square root both sides. X plus 10 over 6 equals positive negative. Now you're going to square root both of these, right? The square root of 49 is 7. The square root of 9 is 3. Came out to be nice numbers, huh? That was pretty cool. In the beginning, ooh, yeah, that looked a little ugly, but now it's not looking so scary, huh? Subtract. And we get these two equations right here, right? Negative 10 over 6 plus or minus 7 over 3. I guess if you want to, you could reduce that a little bit. Want to do that? We could reduce this guy to what? 5 over 3? 2 goes into both of them. Now, since they both have a common denominator, I think this is even simpler. Huh? At least I would hope it's simple at this point. The first one would be what? Negative 5 plus 7, which is 2. So it would be what? 2/3? Negative 5 minus 7 would be negative 12 divided by 3, which would give me negative 4. Those are my two answers for that problem. Okay? That's it. Okay, that's a case of completing the square when a is not 1. There's 2 examples there. Let me just make some side notes to wrap up this whole entire video. First, let's go back to the nicer case for right now. And I'm not sure if I mentioned this in the first video. Another way of doing this, and you'll see this in my answer keys too, you could add 25 over to the other side. Okay? Then, factor your 5 out. Just like that. Okay? Complete the square. So that has to be a 4. So we get 5x plus 2 squared. Now, remember right here, we subtracted 20. Well, because it's on the other side, I'm not subtracting 20, right? What did I do on this side, essentially? I added 20, because when I factored out the 5, it was really 20 here. So since I've added 20, I'm going to add 20 to the other side. That way the equation is in balance. Now watch what happens. This is this guy, right here. Okay? Once again, if you would like to do that, all right, if you want to, add the constant to the other side and go from there, I'm fine with it. Okay? That's just another way of looking at it. You might see that in different textbooks or just other teachers teaching it that way. In fact, I taught it that way too. I just changed my method a little bit to work with the framework that I did in the previous lessons. That's it, guys. If you have any questions, let me know. But until next time, I'll see you all in the next lesson video. Take care.